Good morning, everybody. Welcome to class this morning. As we get started here today, I just want to give you a thank you for watching, whether you're here with me live or you're watching this later. I just want to tell you that I appreciate you watching, even though, it is kind of designed to where, you kind of have to watch these live streams to get all of the material. It's one of those things where I hope you're finding these valuable. I hope you're finding these useful. I hope you're finding them at least a little bit interesting. And I appreciate your time because, you have choices in terms of what to do with your time. So, taking the class and sitting and watching these videos is well appreciated. So today we're moving on to Module 4. And in Module 4... we've got some new stuff to look at. We're going to look at writing our own methods, and that's going to be kind of the focus of our live stream today, is getting on to writing new void methods. But I wanted to start out with just something a little different to introduce you to the math class in Java. And so when we say math class here, what we're talking about is not, what you might expect when you hear the words math class. Like, I'm not going to go sit in a room and learn algebra for, hour and a half twice a week. Our math class, we could also call it our math library in Java. There's a lot of different names that we could use for this. Math class, math module, math library is a series of functions or a series of methods. We are using Java, so we should say methods. There are a series of methods that exist inside of the Java code base that allow us to do more advanced mathematics. So as we approach more complicated problems that might require some more complicated math, one of the important things that we need to look at is this class that's already in the code base. It's already baked into Java. That's going to give us the opportunity to do more advanced math, better math, than we were able to do previously just by using our arithmetic operators. So as we say that, let's start talking about the math class with just a little bit of a review. Right? In terms of doing math so far in Java, essentially all we've done is we've just used our arithmetic operators to do basic calculations. We've looked at plus, minus, multiply, divide, and our modulo operator. And so we're able to do those to get some interesting stuff. Like we have a basic expression here of a variable declaration, and we've assigned it 5 minus 3. So here we're declaring an integer, a variable x equals 5 minus 3. So our Java program knows how to do that math. It knows how to interpret that math, and it gives us a value of 2 that we're putting in this variable container, which is all well and good, right? But what if we need to do some stuff that's a little more complicated? And you've kind of run into this already, and some of you have already discovered the math class a little bit as we've done some of our other calculations. Even though we were able to do those previous calculations with only operators, if we approach it from that direction. However, we can use this math library, or this math class, to do some more complicated functions. So, this math library is in java.lang.math. So last week, we looked at the structure, and we talked about, we have the language, and the this and that, and the class. And one of the things that we said about classes previously is that classes always start with a capital letter. So that's how we can tell that math here in Java is a class, because it starts with a capital M. So whenever we refer to the math class in our code, we will always put a capital M on the start of the word math. Now, remember, as we've discussed previously, as our computer is interpreting the code, it interprets capital letters or uppercase letters, as you might want to call them, versus lowercase letters. Uppercase versus lowercase are two completely different letters. So if we're referring to something that's inside of the math class, we need to make sure that we're using capital M math as the identifier for the class for the methods that we're going to be running. So to do our more complicated mathematical functions, we're using the math class. The math class is located in the Java Lang library. So, you have your language, then you have your library, then you have your class, then you have your methods, then you have your, if you remember back to last week where we had that diagram up on the screen where we were kind of going from big to small in terms of, Java-specific language, right? This is considered a class. However, in other programming languages, if you're used to other programming languages, you might call it something different. Because different programming languages have different names for things. So this class contains methods for performing basic numeric operations like exponent, logarithms, square root, trigonometric functions, all sorts of stuff. Now, one of the great things about our math class is that it is something that we don't have to import. Last week we started talking about scanner, and we were using scanner in our programs to take inputs from our user. And we said that whenever we use scanner, so our program knows what scanner we're talking about, we have to import scanner. But our math class, we don't have to import. And we have a lot of powerful methods in it. And what I want to do is I want to just take you over and I want to look at the documentation. And so you might think, well, why would we're going to look at the documentation? Like, you're going to take me to Google and click on a website and then yes, because documentation is something that's going to be super important. It's super important now. It's going to be super important going forward if you plan on going out into the world and getting a job as some kind of programmer or developer or whatever. Because when you look at Java, Java is a big language. And so you need to have kind of the instruction manual if you're going to be using something that big, because there's going to be parts of the language that you might never use or you might only use on a rare occasion. And so this documentation gives you that ability to go look it up and see how you use it. And it's completely okay. And we have to, right? It's part of if you're a professional, most likely, if you run into a problem that you've never had to solve before, or you have a brand new situation that you encounter rarely, you're going to have to go back and you're going to have to look at the documentation, because there's no way that you can memorize everything, right? Trying to memorize all of this stuff is kind of crazy, because there's just so much of it. And, you don't know if you'll be in Java or in Python or in C++, or, when you go into a coding career. So one of the more important things, as we've discussed previously, is just having a good understanding of the logic, how we put the pieces together, and then using documentation, using external knowledge factors to help you out with syntax when you need it. So we can look at our Java methods library here, or our Java math class here. Just all the wrong words came out when I said that. And all I've done here is I've just Googled Java math methods. I could have also Googled Java math class. You get the results here. Our first two results are exactly what we want. We have the math class for Java 8, and we have the math class for Java 11. And the interpreter that we use, if we go look at our REPL, if we look at the interpreter that's running here in our environment, it's an 11 interpreter. Although between 8 and 11, there's really no difference in the math library or the math class here. So we could use either one of these, but to be perfectly correct in the one that we're using, I'd like to use the 11 version. And we can see that they come direct from Oracle, who, they're the maintainers of Java. They own Java, if you will. So I can just click on this link here and I can see everything that's available to me in the math in the math module or in the math library. And we can scroll down through here and we can see all kinds of stuff. Like we have some static values. Like we have the value for E, which is the base for natural logs. We have pi, you know, and it's going to give you a very precise value of pi, so you don't have to remember that every time, which is pretty cool. And we can see here that our values for E and our values for pi utilize capital letters in their names here, right? Because they're constants. And I think we talked briefly before about using constants in a program and how we write the names of constants in all caps whenever we create that variable as a constant. You know, we did the final, like this would be final double capital PI equals 3.14, so on and so forth. If we were to look in the math class and find this piece of code. But we can also look at a lot of the other stuff that we have here that we can do with various things. Like we have absolute value, returning the absolute value of a number. So if you might get a negative, you might get a positive, which is something that in the guess a number game you might have wanted to do, right? Because when you're returning the difference between the two numbers, you might just want to return the absolute value of the subtraction problem. Might have been something that some of you ran into. You know, like if the guess was smaller than the random, or was larger than the random number, and you were taking the guess away from the random number, you would end up with a negative number. But if you took the absolute value of that number, then you would have the distance, whether it was positive or negative. You know, it'd just say, oh, you were off by 23 or whatever. So that would be something to use. The arc cosine, you know, got some nice trigonometric functions in here. Sine, cosine, tangent. Ceil here is a pretty good one. Returns the smallest, closest to negative infinity double value that is greater than or equal to the argument and is equal to a mathematical integer. So what that does is it essentially just takes your floating point number, rounds it up to the next integer. You could also, there's also floor in here somewhere. Here it is. That takes it and rounds it down. So if you need to round up or you need to round down, you can use this. There's all sorts of stuff in here that you can go in here and read. Max, which is going to be crucial to you in for your one of your assignments that you're doing this week. Using the max, math.max here to find the greater of two values. We have the min to find the lesser of two values. All sorts of stuff here. That we can take advantage of and we can use. And so we are going to use some of this in our big demonstration program for today when we get there. But I'll show you a little bit of it now, right? So let me just head over here into a REPL that I already have open and waiting for us. We'll zoom in here. And so we're going to be working in the main method here because that's what we've been working in so far, right? After we do this, we're going to talk about how to write our own methods and how we can do that. But right now we're still working in the main method. So I could do something like, let's take an input, right? So let's import our scanner. So import Java dot let's see, that's java.util.scanner. And we'll create our scanner object, scanner user input, whatever we want to call it, equals new scanner system.in. And so we'll take two variables, right? We'll create two variables. We'll just pass them to, just some integer variables here. We'll make it just a quick proof of concept program to find the smaller of the two numbers. Right, so what I might want to do is I might want to take a variable, call it number 1, and set that equal to user input dot next integer, or next int. And before this, we want to prompt our user, right? So let's not get ahead of ourselves here. So we will system.out.print, enter a whole number. Then we will system.out.print to prompt for the second number, enter another whole number. Remember that when we create our scanner object, that's our listener object. That's the one that's out there listening. So we only need to create that scanner object here that I have on my line 6 once, and then we can use it multiple times. So I can pass the value of number 2 equaling user input dot next int here. And let's see, I forgot my semicolon here, I also do a Python class a couple days a week where you don't need semicolons. So, it gets a little, when you're programming in as many languages as I am in the same week, it gets a little touchy. So now we have these abilities to take and pass an integer to a variable 1, variable 2. So now let's create another variable. Like, we could just print it out directly to the print statement, but let's put it in a variable to kind of hold on to our composition rules. Take our program, break it down into smaller parts, right? So I might want to take something and call it smallest number. And you know what? That's something that we've forgotten to do here. Again, programming in Python too much. These need to be integer variables. We need to declare the variable type. Glad we caught that before we got our error. Got to declare that data type for our strict type variables. And we can take our smallest number, and whenever we're referencing something from the math class, we need to start with the class name. Just like we do, like when we're working with the system class here, we have to say system.in or system.out. Right, so when we're working with the math class, we have to work with it likewise. So we have to say capital M math.min. And so that's going to find the smaller of two numbers that we put into an argument, into the arguments of this method here. So that's going to be number 1, comma, number 2. And so now we can print to our console the smaller number is, and concatenate that with smallest number. So now we can have our user input 2 numbers. Our code will pick out whichever one's smaller using the math library or the math class. Terminology, it's crazy. Using the math class, you'll take in 2 arguments, number 1 and number 2. pick the smaller number of the two, print it out to our print line. So we can run this. Give it a moment. So we can enter a whole number, like 12, enter another whole number like 16, and we get the smaller number is 12. And so even if we took and we spun those numbers around the other way, where our first number is going to be something big, and our second number is going to be something small, like 25 and 6 here, it's going to give me the smallest number of 6. And so again, we're going to use our math class some more when we get to our big demo for today. But this is a nice proof of concept for us to kind of get started with using the math class. Remember, as you're looking at your documentation here, you've got all this documentation. It tells you which arguments that you need beside the documentation. And that when you reference any of these, you have to also reference the class that it is a part of, which is the math class. So you end up getting something that looks like our declaration here on my line 14, math dot whatever. And then if it has any arguments, you put those arguments in between the parentheses. And we'll talk more about arguments in just a minute as we're talking about methods. So let's leave this kind of hanging out on the back burner for a little bit. And let's talk about writing new methods. And we will we'll come back to this and we'll kind of reformat this to be something that's different, that's new. We'll refactor this code here to use multiple methods after we talk about methods. So let's start our discussion about methods having a look at kind of what we've been doing so far, right? So up until this point, we're only used to using one method, which is the main method. Right? And we've been doing everything inside of that main method. You know, it's the method that REPL gives us by default. It's the method that we've said has to be there, right? Because that's the method in which all of the code that we have to run runs. It runs in that method. And so every time we've created a new method or a new REPL, we see the following method. We see this hello world program. And it looks like this. And now we just talked about classes. We talked about the math class. And in this instance, we have the main class. By default, in our REPLs that we get a main class. And the name of the class corresponds to the name of the file. So like if you look over there on the left-hand side of your REPLs, where you have your file list, you'll see that your file is called main.java, and that relates to the name of that class. If you looked through the code base of Java, you would find the math class in a file called math.java. And so that's the item that we have here. Now, one of the things that we need to kind of discern ourselves away from is the idea is to make sure that we don't conflate this main that we have in this statement here, public static void main, with this main that we have here. This main and this main are completely separate. Our class is called main because that's just what our REPL, our IDE, names the file by default. This could be anything in Java. This can only be main. We need this main method in our program. Because what happens here is that the main method takes precedence in our program. So everything in the main method is what runs as our compiler or interpreter goes through our program. So if we want to write other methods, what do we need to do? Well, in writing other methods, essentially what we're doing is we're more or less doing the same thing that we've been doing with, or that we've been looking at rather, with that main method. Like the structure of the first methods that we're going to start writing here are going to be publicly scoped, static, void methods. That's all we're going to be working with for now, are these void methods. So when we're working with method names, we should begin with a lowercase letter and use camel case, meaning that if you start a new word, that's like the second word, it's all one word, and you capitalize that second word. When we get into our example, you'll see this in action. Now, after we've written a method, it's not enough just to write a method. It's not just going to run by default. Once we write that method, we have to also invoke that method, which means we need to call that method inside of our main method in order for our interpreter to know that it's supposed to run it. Because remember, everything that's in that main method is what our interpreter runs. So if it's a different method that's outside of that main method, it's not going to know to run it unless you put a call to that method inside of that main method. So we can run our new method as many times as we want, or invoke it as many times as we want inside of our main method to kind of help us do our job. So let's go back to that REPL now. And let's refactor this code. Because right now, everything's in our main method. But what I'd like to do here is I'd like to take at least this portion, since we're just working with void methods right now. If we were working with value methods, which we'll talk about, I believe, in the next module, if we were working with value methods, I would take all of this and put it into some other functions. Although I guess we could if we set variables. Yeah, let's take all of this and put it into some other functions. So I'm going to create a function to get my input, and I'm going to create a function to do my calculations. And so one of the things that we want to kind of work with here is we have this main method, right? And when we see the structure of the main method here, this is a similar thing that we're going to follow. Now, one of the things to notice is that we have this class. This class has a pair of curly braces. These curly braces belong to the class these curly braces belong to the method. So as I write new methods, I need to make sure that my new method is outside of the last curly brace of the previous method, but inside the curly brace of our class. So let's write a new method. We'll call it, we'll just call it something like get number 1. Or just get number. Get number would be fine. Because we're going to show how we can actually, since we're using two numbers, you know what? Yeah, get our numbers. That'll be the best way to do it. So we'll get both of our numbers in this method. So we're going to write public static void get numbers. And that's that camel casing that I was talking about there. Right? And you can also see that it's below this curly brace, but above this curly brace. Now I'm going to use these parentheses because these parentheses help me to denote that this is a method. Now what I might also need to use are arguments to our methods. So this one won't take any arguments, but our next function or our next method that we'll write will. So we'll talk more about these arguments when we get to that point. So now I've created this new method, and I can basically just take this code that I've written here in my main method, cut that out, move it down here to our new method. Now, what is kind of the point of a method? We can talk about kind of the point of a method here, because you can kind of see it as you look at like the math class that we looked at earlier. Each of those items that are on that list are methods. A method does one specific thing. So if we want our code to be able to do one specific thing, then we can write a method that does that one specific thing. And then as we flesh out our program, we can have multiple methods that all do one thing or all have a singular purpose. Like this one's going to get our input. We're going to have another one that's going to do our calculation and figure out which one is the smaller of the two numbers. And so what this is also going to help with is composition. Right? Because as we write these different methods, what we can do is we can isolate these methods and we can test them as we go along. For example, like if I'm just writing a new method here and I wanted to write something, I will cut this code so we can get it back in just a little bit. But if I wanted to test this method here, well, what I could do is I could just write a couple print statements, system.out.print number 1, system.out.print number 2. And then I can run this function or run this method to test to see if it works by just taking in the numbers and then echoing them back out to me. Because that's all that I want this method to do, is be able to take my numbers. Now remember that if we run this, it's not going to do anything. If we run it right now, it's not going to do anything because there's no code in our main method. We need the code that we want to execute to be in that main method. So in order to get this to run, I need to invoke my getNumbers method inside of my main function. So now when my interpreter gets here, it's going to see, okay, get numbers. Great. I'm going to get the numbers. I'm going to run this function. I know that function. I'm going to go run it. I'm going to go find it and run it. So now I can test this. We'll give it a minute to kind of spin up. Enter a whole number, 16. Enter another whole number. We'll say 41. And when I hit enter here, what I should be able to expect is I should be able to expect to get these numbers just echoed back out to me. 16 and 41. Boom. 16, 41. Great. We use print instead of print line, so it printed them all together. Doesn't really matter because we're getting rid of this code. This is just test code. So now what we've done here is we know that this code works. So now if I write things in other functions, I don't have to come back to this function because I already know it works because I tested it. I did something that we call intermittent testing. I tested this code and I know that it's functional. So if I'm writing a new method and there's a problem after testing it, then I know that I can focus my troubleshooting on that new method that I just wrote because I've tested this function and I know that it works. So let's write that other method. Let's write that method to do our calculations. So I'll write a new public static void public static void. And we are just starting with these functions. There are all sorts of different types of methods that we would write and all different sorts of words that we would use here. We'll talk more about them later on. We're starting small. This will be called do calculations. And in this function, we're going to take these parentheses and we're going to put arguments in them. And an argument in a function or an argument in a method is kind of like a variable that is only good for that method. So I could create some variables here. Maybe we call them int num1, comma, int num2. And so now I can use these variables num1 and num2 inside of my function or inside of my method. But what these are good for is they allow me to take data from other parts of my program and import it into this method, which we wouldn't be able to do otherwise. And so we can kind of see that as we kind of refactor this, right? So if I paste my code back here, right now I'm not doing math.min of number 1 and number 2. Because since number 1 and number 2 are inside of this function, these functions are completely isolated from one another. Right? This function, unless we do some other stuff like create objects and do several other things that we'll talk about later, this function can't see what this function has going on in it, and vice versa. So we're not worrying about number 1 and number 2 anymore. We're working with num1 and num2. Whatever we have being brought in as these arguments. So now whatever value gets brought in as num1 gets put here. Whatever value that gets brought in as num2 gets put here. So now all we have to do is we have to invoke this do calculations function. Now when we're writing void methods like this, one of the easier ways to kind of deal with this is to invoke the next function inside of the previous function. So if I invoke my method inside of my getNumbers method, and we say do calculations, then when my interpreter hits this, it's going to say, oh, okay, I need to run this other function because I have this new method that's been invoked. So I'm going to go find that method and I'm going to run it. But now this method has arguments, so we need to pass it arguments. So the arguments that we pass it are going to be number 1, whatever's in our container variable for number 1, and number 2, whatever's in our container variable for number 2. So now the structure of this kind of works like this, right? So we get our input here. We put our input in this container. We get another input. We put it in this container. So we transfer these values into our call or into our invocation. In Java, you'd call it a method invocation. In some other programming languages, you'd call it a function call. It's essentially the same thing. So what happens here is this allows us to take the data from this method and transfer it to this method. Because otherwise, as we've said, these two methods are walled off. They're separate. So it takes this num1, puts it in that value because it's the first in the list, takes this num2, puts it in that value because it's the second in the list. So at this point, the values that we have put in here change their names. So now they become num1 and num2. We could still follow this chain of where the number's coming from and where the data's going. But essentially all that's happened here is since we've scoped these arguments for the method, we've just taken these values and we've changed their names now inside of the new method. So we would take those numbers and we put them in here. So if we followed the path from beginning to end, that's the same number. We're just using them in the arguments to be able to take our numbers that we get in this method and put them in our calculations method. So now we can run this, and it's going to work exactly the same as it did before. Give our interpreter a moment to interpret. Oh, what did we forget? Cannot find symbol, do calculations. Ah, a typo. Those typos will get you every time. Calculations. I know you're, like everybody watching this right now is probably just screaming at their computer monitors about the typo that I made. But typos happened. Now let's run it. Give our interpreter a minute to understand what's going on. Enter a whole number. We'll enter in like maybe 55. Enter another whole number. How about 3? We get the smallest number is 3. Runs exactly the same, but now we have our different parts of our program isolated in their own methods. And so as we kind of go through this, we can follow the path to get us from this method call. Because when we invoke this getNumbers method here, our interpreter runs this. So it goes through all of this. And then at the end, we have this other method invocation, which in turn causes it to run this. And gives us what we want. So I want to talk about a few more things here. And I think some of this is just going to be kind of some of the stuff that we just discussed as we're talking about invoking our methods here. Whoops. Accidentally closed my slideshow. Let me bring it back. So what we just did, we essentially invoked a method in our main method for the code to be executed. So if we can also invoke methods, and we can also invoke methods within other methods that we create. So that's what we just did. Right? We invoked a method in main, we invoked a method inside of the method that we invoked in main. So it's, so we saw that kind of work. Right? In order for that second method to run that we wrote, we still had to invoke the method that contains that method inside of the main method. Now we also have this other concept that we'll learn more about later, which is called recursive methods. Which with a recursive method, what you're doing is you're invoking a method within itself. Now we need conditionals before we can talk more about recursive methods. So we'll get a little bit deeper into what's going on here once we get to conditionals, which might be the next module. I can't remember the module order. But essentially what happens here is this causes the method to enter a loop. Right? Because, it's running the method, hits the method invocation at the bottom, and then causes it to go back up to the top and run the same method again. So it's just going to keep consecutively running this method over and over and over and over and over again. which is why we need conditionals in order before we can do recursive methods, because we need to be able to stop our recursion, i.e. terminate the loop, which we have there. But that'll be a bigger discussion for another day. We looked at arguments there, so let's just talk about arguments a little bit, because we used arguments in our last example there, and we kind of explained them, but let's have them here so we have them on a slide that you can see. In Java, information within a method is only utilized within that method. We say that it's scoped to a method. So if we want to take pieces of data from one method and transfer them to another method, we use arguments. And so as we just did in our example, we can declare those arguments as a part of the declaration of our new method. So we just saw this, like we did something similar in what we just did. We kind of declare a variable in these parentheses in the head of our method. And then we can use that variable inside of that method. And then when we invoke that method somewhere else, we invoke it with some other data in there that'll take the place of those argument variables as we invoke that function. So let's wrap up with a little bit of a bigger program. It'll probably take us a little bit over the hour mark, but we should be pretty close. So I'm going to create a new REPL here, a new Java REPL. And this will be, because we're going to be doing like a circle calculator, right? So let me name it here. CSC 151, Sp21. This way we can kind of use all the skills that we've learned today about our math class and all of our different methods. So what I'm going to do here is I'm going to write a program where we're going to have our user enter in a number that's going to be the radius of a circle. And then based on that, we are going to get we're going to display back to them the perimeter of the circle and the area of the circle. Right? So since we're taking something from our user, one of the first things that we're going to want to do is we're going to want to import our scanner class. So we're going to import java.util.scanner. We'll use that a little bit later on. We can remove our system.out.println line here from our main method. We'll use this later for function invocation. In fact, you know what? If we want to use that line, one of the things that we could do with this is make it like a program title. So that would be kind of interesting, and then we wouldn't have to delete this line and let it go to waste. So maybe we would want to write something like, you know what? Let's do something kind of cool. Let's Windows key semicolon here to bring up our emoji keyboard. And let's use like a symbol here instead of we'll call this circle solver. And we'll use that same symbol and put that there. And then we'll do like the escape new line character to give us a break between what's happening here and what's going to happen on our next, in our next function or on the next line. All right, so like if we run this now, we can see we get circle solver. And we might want to put an extra space here just to make it look right, because it's like right up against that. I actually didn't know that the emojis would work in the console until like a couple weeks ago. I tried it out in the Python class. So up until this point, like whenever I was doing something decorative here, I'd use like ASCII symbols. But at least our REPL console here is able to interpret the emoji. So when we want to do something kind of fancy, it's kind of cool. You know, even though we're just making kind of console programs here. So now we have a title to our program ready to go. So let's write our function now that will get us our user input. Right? So what we'll do is we will kind of do it the way we did before. We'll write our public static void user input. Now, if we want to here, one of the things that we could do is add something like string message as an argument. So this way we could add the message that we put in our print line when we invoke our function. So what that would do is that would make our input function here a little more flexible and something that we could use in multiple programs if we wanted to. But this is just something that we're kind of doing here to give it a try. You know, kind of use, you know, as we're practicing, we want to try to use as much of the stuff that we're learning at a time so that we kind of get used to it. Right? So curly braces. And now what I want to do here is I want to add, I'm going to create a double. I'm going to create a double value. We'll call it double radius in, and we'll just declare it. And we'll assign a value to it later. Right? So, and I'll also create my scanner object. So scanner UIN, just whatever we want to call it. I like to use the, remember, like if you get into the habit of like using one thing for it and you like to do it, call your scanner object that every single time. I like to give mine different names just to show you that they can be named whatever you want to name it, just so you don't think you're shoehorned to one thing or another. And we'll set that to scanner new scanner system.in. We will system.out.print the message that we're bringing in as an argument. And then we'll take radius in, and we will pass it the value of un.next double. And so right there we have our input. And so we can go ahead and test it right here if we want to, just by adding a system.out.println statement here with radius in as the value that we're printing. So now once we invoke this method in main, right, user input, and give it a string for an argument, enter number, we can give this a little test. So we get circle solver, enter number, because that's the string that we're passing into here. We enter some kind of number like 12, and right now it should echo back to us 12.0 because we're bringing it back as a double. 12.0, very good. So now we can take this test line and we can remove it, because we know that what we've written here works. So now we can write ourselves another function. And this can be our perimeter function. So we can public static void CIRC perimeter, and we're going to give it an argument of double radius. We'll call it rad in. We'll just call it something a little different because we're going to take our argument. We're going to take the value that we get from here, pass it through to here as the argument. And we'll add our curly braces. And so in here, we're going to take the radius. Because to get the perimeter of our circle, we take the radius and we, let's see, it's 2 times pi times the radius. Right, so we can create a function here, or a variable here of double peri equals. You know what? Let me just check my math right quick just to make sure I'm using the right equation. Yep, 2 times pi times radius. Yeah, because it's diameter times radius or diameter times pi. The area is diameter times pi, so if I get 2 times radius, then it's what I want. So I can, right here, 2 times rad in, which is the argument value that we are bringing in from another function, times math dot capital P, capital I. Gives us that full pi value. So now we can system.out.print line, and we'll refactor this part a little later. Perimeter of the circle, and we'll add the we'll concatenate the value of peri, and we'll concatenate another thing that's like units, just so we have something that's kind of complete here. So now if we go into our user input function, we can invoke our circ perimeter function from there. So we can say circ perimeter, and it's got our double value of rad in, so that's going to be radius in. And now we can test that to see if it works just by running our program. So it's going to run that user input function first because we have it here invoked in main. So since it's invoked in main, what's invoked in main is what runs. So it's going to run this function. But since running this other method is a part of running this method, it's going to go ahead and run this other method. So we can enter a number like 6, and it'll give us that perimeter of the circle is 37.6991111 units. Cool. Now we'll go back and we'll reformat that line because I don't necessarily want that level of precision here. So we'll reformat that line a little bit. But let's go ahead and write ourselves our other function before we go back and refactor. And that's going to be our area. So we'll write a public static void circ area. And that'll also need a double of the rad in. And we can call it the same name if we want to as we called it here. Because remember that these are only scoped for their particular function. So it's understanding rad in here. It's understanding rad in here. They could be 2 totally different things because they're only for that particular function. So now we can take a double value of area and set that equal to the equation for that, which is going to be math.pi times radius squared. So we can use our math.pow method for that. So that's math.pow because that's going to give you an exponent. So you enter in one double, and then you enter in another number that's going to raise it to that power. So I might write rad n, comma 2. So that's the radius n that we're getting raised to the power of 2. We'll write another system.out.println here, system.out.println area of the circle area units cubed or squared. Not cubed, we're not dealing with three-dimensional objects here. And we didn't use a period on the other one, so we'll just maintain consistency. So now we can also invoke this function, or this method, inside of our user input method. So we can have circ perimeter and circ area with radius n. And so now it'll run both of these. It'll run the top one first, then the bottom one second, because it's still executing in that linear order. So now we can run this and test it. So we can enter a number. We can enter something like 4. And we get the perimeter and the area of our circle. Perimeter is 25 point, so on and so forth. Area of the circle is 50 point, so on and so forth. Now, one of the things that I said we might want to refactor here is this fact that I don't really need that level of precision. Right? So in I believe the last module, maybe the module before last, you read about the printf function, but it would be the printf function or printf method, but it's our printf statement where we can actually use some of our code to kind of truncate that double so it's shorter, especially when we don't need that level of precision. So in order to do that here, I would write system.out.printf, which means print formatted. And to start off here, I can write the entire string. The perimeter of your circle is, or we'll just write it the way we had it. Perimeter of the circle and now we can write our formatting line in here, which is going to be from percent symbol 0.2 F. So this is our formatting code for our printf method. So when it sees that percent symbol, that's when it knows that this is the format stuff. Then I'm saying 2 points in a floating point number. So we're going to round to 2 decimal places. Units. And then I can add a comma peri to this. So now it'll take the value of peri and it'll put it in this place. And we can do something similar with our other statement. To save us a little time here, I'll just copy this statement and change the pertinent parts. So instead of perimeter of the circle, it's going to be area of the circle. We'll add units squared. And instead of peri, we'll have area. And so now we've refactored the code to where we won't have all this precision. We'll just have it to 2 decimal places, which good enough for what we're trying to do here. So let's run this now just to see that. Enter number, and we'll enter 4 again. And you'll see that perimeter of the circle, 25.13, area of the circle, 50.27. Now we can see that printf does the same thing as print here. puts them all on one line. And we can also see a little typo here. I meant to put a colon there, but I have a semicolon. So we can fix that. And we can do a couple things here to get that break. Like we can put our escape end character here at the end of this string if we wanted to. And that'll handle it. Another thing that we could do is just simply put a system.out.println in between our two function invocations here. But really, that solution right there is going to solve it faster. So enter number, something like 6. Parameter of the circle, 37.70 units. Don't have all that extra stuff that we had out there before. Because using math.pi gives us a highly precise number. Area of the circle, 113.10 units squared. Again, you don't have all of the extra decimal places here. You know, if you're doing something that you need precision, leave all of them in there. If you're doing something where you don't need as much precision, you can do this rounding and, you know, it might be more valuable data to you. So we have gone well past the 1 hour mark now. Actually, we're not too far past the hour mark, so we're not doing too bad here. So we're going to go ahead and stop here for today. Have a nice little program here that's going to do our circle solving for us, giving us the perimeter of a circle, giving us the area of a circle. We've covered a whole ton of stuff today. So this is where we'll stop for today. I'll turn the music back on for a couple minutes so I can hang out and chat, answer any questions if anybody here with me today has them. If you're watching this recorded and you have a question, please email me. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.